Imagine you're on a flight, cruising at 37,000 feet. You're relaxed, comfortable, sipping a coffee. And then suddenly the plane falls 600 feet in 2 seconds. People flying, screaming. Chaos. The pilots have no control. This isn't science fiction. This happened in 2008 on a flight from Singapore to Australia. People suffered from lacerations, fractures, and even spinal injuries. And the cause? A tiny cosmic ray from space. It damaged a critical sensor, and that sent faulty data to the autopilot, which forced the plane into an uncontrolled nosedive. This phenomenon is known as a single event effect, and it is a major concern in modern aviation electronics. As aeroplanes become more electric, we need power devices that can dissipate the energy from a cosmic ray more effectively. My research centers on silicon carbide, a new material with high efficiency and great potential for high power applications. But it's critical we demonstrate that it can operate in extreme environments. Now, to consider how these energy bursts damage electronics, I want you to consider a narrow pedestrian bridge, say Kingsgate Bridge, for example. We want to control the flow of people. This will represent our energy. At each end, we'll install those one-way supermarket gates, the ones that are impossible to get out of if you just want to leave the shop. This acts like a diode where the people or energy can only flow in one direction. Now, take a normal day. What if we flood that bridge with 100 people? Okay. What about 1,000, 10,000? At some point, the bridge will collapse. This is exactly how electronic devices degrade. Even if they don't fully fail or the bridge fully collapse, they will still suffer some irreparable, invisible damage. My research recreates these energy surges using lasers. We inject a carefully controlled amount of energy and see how and when devices fail. It allows us to build and design new devices that are more impervious to these cosmic rays. If we get this right, we make aviation safer, greener, and more efficient. Imagine a world where more airplanes, or more parts of airplanes, are powered by electricity. We reduce the cost of fuel, we reduce our carbon emissions, and critically, we increase the safety and reliability of air travel. Because when you spend your day at 37,000 feet, the last thing you want is for a cosmic ray to bring everything crashing down. Thank you.